at this point we understand a bit about how prototypical inheritance works, right? How a string can inherit from the string object, which itself inherits from the object, right? Same with, say, an array or even an instance of an object. We know about constructor functions to create instantiated objects. But what we haven't covered yet is inheritance in terms of creating constructor functions that invoke another constructor function. So what I mean by that is right now we have kind of a generic animal constructor. Right? We take in name, age, and breed, and it doesn't really matter what type of animal it is, it's always going to have these properties. But what if we want to be more explicit? What if we want to have a dog object represent a dog, for example, or a cat object represent a different type of object, right? They're all animals, so they're going to have some things in common, but they'll also have things that aren't in common, right? So not all animals we care about the breed. Let's say breed, in our circumstance, we only care about for dogs. So how can we address that? How can we inherit some things from animal here, depending on what object we're instantiating? So let's take a look at that. So you know what? I'm not going to be concerned with breed on the animal. And you can sort of think of this as sort of a parent class in a way. So this will have some things that all animals will have in common. And what I'm going to do is I'm going to comment out these two dog objects. And what we'll do is we'll create another constructor function that's going to inherit some properties from animal. So let's do that. So we'll say function dog. Dogs will have a name, dogs will have an age, and dogs will have a breed. And you know what, in say breed, I'm going to change this to make noise. That's what animals do. And we'll just have it say generic animal noise. Right, so unless we define otherwise, our animals will just make generic animal noise. Not that there is generic animal noise, but I think you get what I mean. All right, so notice that we are taking in one argument that we're not taking in for animal. Right? Animal, we just need the name and the age. Dog, we take name, age, and breed. And the first thing we're going to do is we're going to invoke basically a special function called call. And, well, not really special, it's just built-in function. And call allows you to call a function that's defined elsewhere in the current context. So in the context of, we're in function dog, we're going to pass through this to let animal know, what we're referring to. And that's going to invoke this constructor function for us inside another constructor function. And I will say as well, we're going to get into some ES6 ways of doing this, which does make things a little bit easier. So I would say just try to follow along as best as you can, and then we'll get into the ES6 methods instead, which are a bit more easier to grok, I think. All right, first things first, we will do animal.call. And the first argument of call is where you give it the context, which in our case is going to be this. Right, so this is the context we want to invoke this function in. The other parameters will just be the arguments that this function takes, which are going to be name and age, that we're just going to pass through when we do animal.call. Okay, finally, we are taking in breed. So we'll say this.breed equals the breed that we pass in. So this should allow us to instantiate an object that is a dog that inherits certain properties from the kind of parent class or parent object. Let's try it out. So we'll say const Barky equals new dog, name Barky, age 1, breed, we'll make it a Chihuahua. Okay, let's see if we try to do Barky.name. Let's see if this worked. Console log Barky.name, save it, clear, run. Hey, looks like it worked. Right, so even though we didn't define this.name equals name, it invoked this constructor function for us because we're doing animal.call. Right, we're inheriting this object where we define this.name equals name, this.age equals age, and we're also defining the breed. One thing we should be aware of though is that currently, if we try to say make noise, let's see what happens. Barky.make noise. Clear, run, error. Make noise is not a function. So we do need to take another step to define this method on our dog prototype object, right? And we basically need to add in any methods we want, we need to make sure we specify, hey, I want you to inherit the prototype methods as well. One thing you can also take a look at, which is kind of neat, is you can take a look at the prototype.constructor, which currently will be a reference to the function. If we clear this and run it, you can see function dog. It just shows us the function. If we look at the constructor itself, it's just going to be an object. And if we look at it in the dev tool, so if I do Alt or Option Command I on my Mac, it's going to take me to my dev tools, and then we can kind of pop it down and take a look at it. So we can see there's constructor, but there's no method in my prototype object. Right? Contrast that to if we do animal.prototype, we'll be able to see that it does have a make noise method. Right? So we just need to make sure that we pass through that method to our animal.prototype. And it's pretty straightforward to do, but a little confusing again. So I would say, again, just kind of keep watch, and we'll get into ES6 ways instead later on. But we basically say, okay, so the dog prototype object, I want you to be equal to object.create. And we'll basically clone in the animal.prototype object for the dog prototype. Right? In other words, we're passing through the entire prototype for animal, including where we define a method on it. One other thing we need to make sure we take care of is this will also pass through assigning the constructor of animal into dog, which we don't want to do. Right? So if we take a quick peek at that, so dog.prototype.constructor. So what constructor is it assigned to currently? Let's take a look in here. Right, so it's referring to animal, which we don't want to do. We want to instantiate new dogs, not a generic animal. So all we need to do is do one other line of code here and just reassign it. So dog.prototype.constructor equals dog. So just assigning it a reference to this function. At this point, again, if we take a look, console log dog.prototype, we'll be able to see it is there now. Right, so I can already see it here. It's function dog, and if we inspect it here as well, it's an animal, right? So it's not a generic object, and the constructor is directly referencing dog, which is pretty good. So at this point, we should be able to say barky.makeNoise, and it should have inherited that method, and I can see that it did. So again, a little bit of a pain, and again, we will look at the ES6 way, which makes things a lot nicer in terms of syntax. One other thing I wanted to mention is if we did want to kind of redefine this method, because we know it's a dog, we know that dogs bark, they don't just make generic animal noises. So what we could do is we could define it on the dog prototype, right? And it would basically just reassign make noise to a different method. And that's very simple. We just grab the dog.prototype.makeNoise function, and we're basically reassigning it here. So function equals console log bark, bark, woof. Right, at this point, if we run it again, we can see that it's getting past the new method instead of referring to the inherited method. So, if you do need to redefine it, this is how you would do it. Otherwise, if you just want to inherit a generic method, hey, this is how you would do it if you're doing it, the non-ES6 way. Let's do another example to see this in action. And it's going to be pretty similar, really. So we can basically do something like a cat, for example. So I'll say function cat, name, age, and let's say cats. We don't really care about the breed, but we want to know the coloration of the cat, for example. So we'll do again animal.call this, name, age, and this dot coloration equals coloration. Okay, again, we're going to do our inheritance stuff here. So cat.prototype equals object.create, animal.prototype, cat.prototype.constructor equals cat. And let's say we don't really care about make noise. We can just inherit the generic make noise function, but we want to give it a different method, for example, and we can say cat.prototype dot scratch post equals function, and we'll just do another console log here. Cat has scratched the post. All right, let's try to instantiate a new cat here. Const kitty equals new cat, and let's call our cat kitty. Not super imaginative, I know. We'll make it a tabby kitty. All right, let's check it out. Let's do kitty dot make noise. We should have inherited a reference to this method. There we go. Generic animal noise. And what if we try to do kitty dot scratch post? Clear, run, success. All right. Now, as you can imagine, this can get pretty complex pretty quick if you are sort of inheriting from 2 levels or 3 levels up, for example. So if we want to see that in action, we could do that. So we could do function kitten, takes in name, age, coloration, and I don't know, litter number. And we can do something like cat.call this, name, age, coloration, and this dot litter equals litter. Let's see if we can get this to work. So we will do kitten.prototype equals object.create cat.prototype and kitten.prototype.constructor equals kitten. Okay, let's see if we can get this to work. And as you can see already, it's getting a lot more complex than perhaps it may need to be. So this is, as usual, just an example. So const tiny kitty equals new kitten. Let's call it spot. Age can be 0.3 years old. Coloration orange, and litter number 1, for example. All right, let's see if we were successful. tinykitty.name. Clear, run, success. What about coloration? This will test if we were able to invoke the cat constructor. Success. Okay, and we should be able to make noise. Let's see though, and don't need to console log that. Success. Right, so kitten inherits from the cat prototype, which itself inherits from the animal prototype. So not too different in terms of functionality from your classic object-oriented languages, but a little different in terms of implementation with regards to prototypical inheritance. And just to test, let's check to make sure we can do scratch post. Scratch post. Run. Before moving on, I did want to mention that it is possible to check if any particular instantiated object is an instance of this object creator. You might think of it as a class for all intents and purposes. If something is an instance of kitten or cat or animal, for example. And as usual, I've just console logged this out, and we can check that like so. So tiny kitty instance of kitten. This will return a Boolean if it is an instance of kitten. Let's see what it tells us. Yep, it's true. What about if it's an instance of cat? And it should be true. And we can see that it is because kitten inherits from cat. Is it also an instance of animal? And this one, of course, should be true. If we check if it's an instance of dog, this, of course, should be false because dog doesn't come into the equation in this particular circumstance. Now, this could be useful, for example, in our cat scratch post function. We can check the value of this. So, for example, if this is an instance of kitten, console log kitty scratched post, else console log cat scratched post. Okay, let's see if we can get this to render how we think it'll render. So tinykitty.scratch post. Let's try it out. We'll clear, run, kitty scratch post. Okay, what about our kitty, which is just a normal cat? So instead of tiny kitty, we have kitty. Success. Right, so we can check the instance of if you have some kind of conditional you need, or for any reason really, you can check what it's an instance of.